Here I have a demo of basically a simulation prediction, and it's creating a reduced order model of a suspension arm. So this is how the whole process looks like. And the first half, and the first step starts from actually generating the CAD. And then there is also the FEA setup, which we need to do. And here, my input that I'm interested is the part thickness and the force value. So these are the inputs that I want to change. And then I want to get some outputs that are interested to me, in this case, displacement, maximum stress, and mass. So my inputs are these two part thickness and force values, and my outputs are these numbers. But that was just one data sample. And for machine learning models to work, we need more data. Therefore, we use the design exploration to generate a couple of designs, a few hundred samples here. And once I generated them, I can easily use the linear regression model in Synera. Of course, I have to do some data pre-processing. But once I do that, now I can ask the model for this pair of inputs, what's the output? And you see, I already get the 3 output values. Now, that was simple machine learning, but sometimes we need advanced models to tackle highly nonlinear cases. And that's why we have the run FMU add-in in Synera. You can use tools like Altair's ROM Builder or Siemens ROM Builder to generate powerful neural networks without writing a single line of code. And here I'm showing you how it's done in ROM Builder. So I create a new model. So I just pick the inputs, outputs. I pick few number of layers here. I also give it some training settings. And once I do that, you see I already get my trained neural network. And from all these models, I can easily export it as a FMU and then bring it back into Synera. So the whole end-to-end process looks like this. And you can easily do everything with Synera, connect to other tools. But is this the only possible thing? Like I mentioned, anything that comes as numbers and goes out as numbers is done by regression. And that's why another cool demo I want to show you is machine setting ROM. Imagine you have a part for which you usually figure out some numbers only at the end of prototyping, and you have to wait till that time. What you can do with machine learning is curate your past data, put it into an input file. So you see here, I'm just reading a CSV that's basically containing a couple of parameters like length, width, height of the parts, and some machine settings like for additive manufacturing that makes sense. And all I have to do is somehow extract essential features out of this data, like normalization factors, and all of this is done inside Synera. And once I extract these features, I can then quickly create data sets inside Synera, and then I can just send them to a linear regression model again to kind of map the inputs and outputs. And once I have this, I can already see that I have pretty nice accuracy here, around 98, 99, 95, somewhere 93, so room for improvement. But the good thing is, next time I have a design, I don't have to do the full process. I can just take even a mesh input. If I give it to this model, it will extract some geometry, and you see I already get a 98% accurate prediction for some of the key relevant machine settings that I may need in the end. So these are regression models. So you have couple of numbers and you predict a bunch of numbers. And I also want to shortly show you a classification ROM. While mathematically it's not a ROM, we call it a ROM because it solves a very specific task. And sometimes we work with a lot of, not sometimes, always we work with a lot of 3D data, and we want to make use of these. So what I have here again is a data set of various parts. So I have like 1,000 3D parts of different components, and it's basically like a bearing data set. So I have some housing, some bearings, and some bolts. And what I want to be able to do is classify them based on what kind of geometry they are. So I again have some feature extraction. So I process these geometries in a way that makes sense. So this is a logic wherein I get some ratios or numbers that I can make use. And once I have all of this, I can just give it to a multi-class classification. So again, a simple drag and drop in Synera. And then what I can do is basically classify them into 3 different types. And the cool thing is, once I have this, I can use it for subsequent tasks like applying FEA boundary condition and even costing and things like that. So let me do one run here. So I have a bunch of parts that I want to classify. So I send it through the loop. And what I get is based on these classes, I get the predicted classes out. So it's a housing, pairing, and board. And the next step, when I pass this data along with geometry, I don't need to do any manual post-processing. I have logics to just get out the relevant information needed. So yeah, these were some inspiration for you. And I hope we can talk more about these.